Okay, now let's think about gauge R&R. So when measuring the critical characteristics of process, it's sometimes very important to use some kinds of tools, such as a gauge or other tools. So they may be accurate, but oftentimes you can cause problem with variation in measurement. In other words, if you can measure using the certain tool, your measurement may not be exactly the same over time. So there will be a variation. One of the commonly used tools of this measurement system analysis is gauge R&R. We call the gauge repeatability and reproducibility analysis. This is called gauge R&R. So this practice involves some complex statistical procedures. So for this reason, in this course, we will look at them very briefly. So this gauge R&R is used to determine number one, accuracy, number two, precision of your measurement. So very, simply you can use the two-way ANOVA, statistical tool built in your Excel file, built in your Excel. So you have to install, the statistical tools in your Excel. But using this two-way ANOVA, we can determine whether this variation comes from the part being measured or differences in operators. So using the two-way ANOVA, we determine whether this variation comes from the part being measured or differences in operators. So click on this third spreadsheet. This is about the example 13.4, gauge R&R in action. So this 13.4 example contains measurement data. This is a part number. We have 20 different parts, and we have 3 different operators. And this contains the measurement data for a particular operation with 3 operators, taking 2 measurements per part. Sometimes operators, can take 3 or 4 measurements, but in this case, each operator they measure twice. So each part twice using the gauge and logs these measurements. Write down these measurements. For example, operator 1, measures part 1 twice with the 21 and 20 millimeters. The same operator measures part 2 24, and they get 24 and 23 measurement, and so on. So operator 2, measure the part 1 20 and 20. This is exact the same, but part 2 same, part 3 is different. So as you can see, there is a measurement variation. But we do not know actually whether this variation comes from a part or operators. There is another factor we call equipment, but let's think about this only two. Whether this variation comes from the part or from operator error. For this, we have to go to the tools and data analysis. By the way, this data analysis tool need to be installed using the Excel add-in. Then you add in the analysis tool pack and click OK. Then you will see the tools and go to data analysis. And there are a bunch of important analysis tools are included here. We use the ANOVA 2-factor with replication. Click OK. Then here we see the input range, rows for sample and alpha and output options. First of all, you need to include the input range. Here all the way to B4 through E44, all the data range. And then in terms of rows for sample, we measure twice, so we put 2. If we measure the 3 times, then we put 3. 4 times, we put 4. Something like that. Alpha indicate the confident interval, so we usually use the 95% confident interval, so 0.05. That's the default. Then we choose the output option. So output range, just click in random cell that where you can see the appropriate cell. Click, then OK. Then the two-way ANOVA with replication is provided. What is important here is go all the way down to the ANOVA table. You see the ANOVA table include the source of variation and then all other factors, including the p-value. Important thing is source of variation and then p-value. Here sample means part. So we want to know whether variation comes from part or column means here the operator. So there are 2 sources of variation. Number 1 is part or operator. So sample means part and column indicate the operator. Then you look at the p-value. Look at the p-value. That p-value this indicate the very close to 0. And that means part we just provide the summarize based on the ANOVA table. The source of variation is sample is part and column indicate the operator effect. P-value here is basically 0. And here operator effect is a 0.27, so 0.27. 5. This indicate the insignificant. And then p-value 0 is the significant. So the closer to 0 is significant and 27.5% is pretty highly insignificant. So significant p-value indicate that part contribute, sample. Part contribute the variation. While the insignificant p-value indicate the operator effect has no impact on the variations. Operators, regardless of different operator, it does not matter. It does not contribute to variation. That's your conclusion. So we conclude that this variation comes from parts, not from operators. There are more than that, but we can stop here. And for your quiz, you can practice question 14 and 15 using Excel. This ANOVA two-way ANOVA with application. And I will ask the similar question in the quiz. Okay, so let me stop here. Thank you.